हाय फ्रेंड्स, आज आपण SYBCSचा डेटा स्ट्रक्चर अँड अल्गोरिदमचा फर्स्ट चॅप्टरच्या नोट्स बघणार आहोत. इंट्रोडक्शन टू डेटा स्ट्रक्चर अँड अल्गोरिदम ॲनालिसिस. इथे फर्स्ट चॅप्टरचे कंटेंट्स दिले. फर्स्ट पॉईंट इंट्रोडक्शन, सेकंड नीड फॉर डेटा स्ट्रक्चर, थर्ड डेफिनेशन्स, फोर्थ टाइप्स ऑफ डेटा स्ट्रक्चर, फिफ्थ अल्गोरिदम ॲनालिसिस. त्याचे सब पॉईंट स्पेस कॉम्प्लेक्सिटी, टाईम कॉम्प्लेक्सिटी, बेस्ट केस, ॲव्हरेज केस अँड वर्स्ट केस नोटेशन दिलेले. इंट्रोडक्शनमध्ये बघूया. प्रोग्राम मीन्स डेटा स्ट्रक्चर प्लस अल्गोरिदम and data structure means organized data plus allow operation. Need for data structure. Modern day computing problems are complex and large. They need to data large volume. There is a need to store and process information of variety of types: character, numeric, audio, video, graphics, etc. Data has to be stored such that the logical relationship between the data elements is retained. Advantages of data structure. First, data structure is easier processing data. Second, related data can be stored together and in their required format. Third, better algorithm can be used on organized data. This improve program efficiency. Fourth, they provide a means to store, organize and retrieve data in an efficient manner. Third point, definitions. Data is a raw, unprocessed input given to a system or process. Data can be of two types: atomic data, composite data. First, atomic data. Atomic data is a single elementary piece of data which cannot be further decomposed. Example आहे character, number. Composite data. Composite data is a group data item which consists of subfields, each of which is atomic. Example, a date consists of subfields like day, month and year. Information. Information is a meaningful or processed data. The system or process transfer raw data into meaningful and useful information. Data type. Data type describes the format in which data is and processed by a computer. Data object. Data object refers to a set of elements D of a specific data type. This set may be finite, be infinite. Fourth, data structure. A data structure is a set of domains D. A designated domain D belongs to D. A set of functions F and a set of axioms O the triple DFA. Denotes the data structure. D denotes the data object. F denotes the set of operations that can be carried. A describes the properties and rules of the operation. Next point, abstract data structure or type. The ADT is a mathematical or conceptual definition of data structure. The triple DFA is called the abstract data type. Example, ADT. Next point, types of data structure. First type, logical data structure. The ADT is a logical data structure because it specifies the logical properties of the data type. Second, physical data structure. A physical data structure is the implemented ADT which can be used to store elements and perform operations. Third, linear data structure. Data structure where data elements are arranged sequentially or linearly, where each and every element is attached to its previous and the next adjacent, is called a linear data structure. Array, stack, queue, linked list. Fourth, non-linear data structure. The data structure where data elements are not arranged sequentially or linearly are called non-linear data structure. Example, tree, graphs. Static and dynamic data structure. A static data structure is a one in which the size of the data structure does not change during entire program. Example, array. Dynamic. In a dynamic data structure, the size of the data structure grows and shrinks as the elements are added and removed dynamically, that is during runtime. Example, stack, queue, linked list, etc. Sequential organization. In this organization, the elements are stored in memory at any memory location. Details stored in a linear sequential. Example, linked list uses link organization. Link organization काय आहे? A data is stored nodes that are linked together. In this organization, the elements are stored in memory at any memory location. Example, linked list uses linked organization. Algorithm analysis. Program is equal to data structure plus algorithm. Space complexity. The space complexity of an algorithm program is the amount of memory a program needs to execute. The components of space complexity. Two types of space complexity: fixed part, variable part. Fixed part. This part is independent of the characteristic of the inputs and outputs. Variable part. It consists of the space needed by variable whose size depend on the particular problem. Instance, being solved the space needed by reference variables and the recursion stack space. SP is equal to C plus SP. C means constant fixed part. SP means variable part. दोन एक्झाम्पल सॉल्व करून दिले एरिया आणि समचा. त्याच्यानंतर नेक्स्ट पॉईंट बघूया टाईम कॉम्प्लेक्सिटी. द टाईम कॉम्प्लेक्सिटी ऑफ अ प्रोग्राम इज द अमाऊंट ऑफ टाईम द प्रोग्राम रिक्वायर्स टू एक्झिक्यूट. Amount of time an algorithm requires to complete its execution is called a time complexity. Next point is types of statements in a program. Simple operation first. Simple operation involve a single operation or condition, hence it executes in a constant amount of time. Its frequency count fn is equal to 1. Example, a equals to a plus b. The statement a equals to a plus b execute one time, thus its frequency count is a 1. Second, linear loops. In a linear loop, the loop control variable is either incremented or decremented. By fixed value, the frequency count of such a loops is f of n equals to n. Example, for in bracket I equals to 1 semicolon I less than equal to n semicolon I plus plus bracket complete a equals to a into b semicolon. Third point is logarithmic loops. In logarithmic loops, the loops can controlling variables is either multiple or divided during each iteration of the loop. The frequency count of logarithmic loop is f of n is equal to log of n. Nested loops. Loops that contain loops are known as nested loops. Types of nested loops. Linear logarithmic. Here the outer loop is a linear loop and the inner loop is a logarithmic loop. The efficiency of such a loops can be given as a f of n is equal to n of log of n. Quadratic. In a quadratic nested loop, the number of iterations in the inner loops equals to number of iterations in the outer loop. The efficiency of such a loops can be given as a f of n equals to n square. Third, dependent quadratic loops. In this type of loop, the number of iteration in the inner loop depends on the outer loop. Third point is best case, average case, worst case. Best case, it an algorithm is taking minimum amount of time for its execution. It is called as a best case. Less time. Worst case, algorithm makes max means maximum amount of time. Worst case, tn equals to max bracket मध्ये tx1 tx2 up to txn. Average case. Average case running time assumes that all inputs of a given size are equally likely. Algorithm. Average amount of time, not less, not more. Average case. Tn equals to 1 upon all possible inputs. Summation of t bracket मध्ये x1 x2 up to xn. Usually the average case and worst case step count is the same. Asymptotic notation. O, omega, theta. O notation, big O notation. This notation is used to denote upper bounds. Worst case. It is expressed as a f of n, which means that the time taken never exceed roughly f of n operation. It is the most commonly used notation. Omega notation. This is used to denote lower bounds, best case behavior. It is written as a T of n equals to omega f of n, which indicates that Tn takes at a least about n operation. Theta notation. This notation denotes both upper and lower of f of n, written as a T of n equals to theta. J of n. It indicates the running order of an algorithm. थँक्यू व्हिडिओ लास्टपर्यंत बघितल्याबद्दल. जर तुम्हाला व्हिडिओ आवडला असेल तर लाईक आणि सबस्क्राईब नक्की करा.